Hey, so just a short video here to go over water treatment plants, specifically one that I recently visited, the Little Patuxent Water Reclamation Plant in Savage, Maryland. There's different types of treatments wastewater plants perform, and the Little Patuxent is one that has a lot of upgrades that really help keep the water releases clean and with very little bacteria and nutrients. It releases water into the Little Patuxent River, which connects with the Patuxent River downstream and ultimately the Chesapeake Bay in southern Maryland. So I'm going to go over how the plant works in a general sense and highlight some of the upgrades that the plant has made. So let's start at the beginning. The very first part of processing wastewater is removing debris from the water. That's the big physical stuff that goes down drains, and it's exactly what you would think it would be. My tour guide and plant manager Rob mentioned it was a lot of fat, rags, and just, general waste. He mentioned that they found bricks and plywood there before, which you just gotta wonder how. Once the debris is removed, it's then dried and put into this machine, which spins the waste rapidly and dries it out. From there, the debris is further processed to help kill bacteria, and then it's stored and kept for agricultural use in fertilizer. At first, I thought it sounded kind of strange that waste would be used as fertilizer, but it's only used on fields that don't have vegetation made for human consumption. So think like livestock feed or corn ethanol. And that's the silo there that trucks drive under and the fertilizer is dumped right in. This is actually the latest upgrade that the plant has made, which helps reuse nutrients instead of just dumping them straight into a landfill. Another way that they reuse nutrients is through a phosphorus collecting system. Rob mentioned that this is the only plant in the area that has this type of system. The closest one he knew of was in the Denver metro area. This system, made by Airprax, has a way of capturing phosphorus and forming it into pellets, which very slowly break down. So the thought is that they could use this phosphorus in the pellet form to be sold as fertilizer for farmers out in the Midwest who don't have a lot of phosphorus in their soil. So let's move on to where the water actually goes. After the initial debris removal, it goes to the clarifying tanks. Now these tanks push water up through the center and give it time to let gravity start separating the water from smaller particles floating inside, which then sink to the bottom. They also have skimmers at the top which help remove grease and floating buildup. Now this process is going to remove about 45 to 50% of the waste in the water. You'll see in this empty tank there's a skimmer on the bottom that helps remove the sludge to be treated and dried. They keep a few of these empty for cases when there's an unusually large amount of water entering the plant. They're kind of like a backup. For a long time, this was really the main way of processing wastewater, but with technology improving, the new minimal standard for plants in the area seems to be the biological nutrient removal system seen here. Now, this system is important because it helps remove nutrients from the water, which is crucial when looking at the health of the Chesapeake. This system uses microorganisms that are naturally occurring, so you don't need to use any chemicals. These tanks have three sections: the aerobic, anoxic, and anaerobic. Nitrogen is removed using nitrification in the aerobic section and denitrification in the anoxic section. For phosphorus, organisms break the nutrients down in the anaerobic section and then consume it in the aerobic section. You can probably tell, and I won't lie, it's all pretty overwhelming, and I'm still trying to understand the science behind it completely, but it seems to just come down to naturally occurring microorganisms breaking down nutrients and consuming them. Now, in Maryland, most plants are being upgraded to treat water even further using the enhanced nutrient removal system. At the end of the last process, there's still some residual nitrates in the water, so this section uses denitrifying microorganisms that use nitrate molecules to get their oxygen. So essentially what's happening is that they break down the nitrate to gain oxygen, which eventually reduces the nitrogen to a gas, which is released into the atmosphere. The final step is to move the water through a UV light, which doesn't kill bacteria, but stops it from multiplying. The bacteria that is alive is naturally occurring and isn't going to harm the river. So yeah, that's the plant. It has all the bells and whistles that any modern water treatment plant would have. There's a couple plants in the region that don't have quite as many upgrades and have been releasing a lot of harmful bacteria into the bay, specifically the Patuxent and Back River water treatment plants in Baltimore. The plants are being sued for these violations, and they're working on fixing the issues. When I asked Rob about it, he said he's grateful to work in a progressive and wealthy county that has the resources to put into the plan. He says finding the funding to run the plants in Baltimore is probably the issue. To me, I feel like dumping sewage into the bay would be something worth using funds to avoid, but I understand that cities are complex and there's a lot of issues that need to be addressed. So anyway, that's the Little Patuxent Wastewater Reclamation Plant in Savage. It's encouraging to visit somewhere that has seen such a huge reduction in nutrients and waste entering the bay, and I really hope that all the plants in the Chesapeake watershed are upgraded to the system soon. Take care.